Good morning, everyone. Can you all hear me? बढ़िया तो इंटरनेट कनेक्ट.
Nah, temporary internet.
Okay. Hopefully, all of you can hear me and all of you can see the screen. Right. My internet connection is a little unreliable today. Right. It is working, but then suddenly it just gets turned off. I don't know why. So okay. All right then. Let's just quickly go through the homework questions that were sent to you yesterday. Uh, Here are those questions. Okay. Yeah, I tend to click the mouse very, I mean, with a lot of force, right? So, okay. So here's the first question. So the floor of a room is taken as xy plane, and an ant moves from A3, 6 to B6, 2 meter. Find magnitude of its displacement. Also write its displacement vector in standard form. Okay, see there is not much to explain in my view. We have already talked about such things often, right? So this is initial point 3 comma 6 meter. See, I'm not drawing it exactly, I'm just making a rough sketch. Okay, everyone, I'm just making, oh sorry, I'm just making a rough sketch. So it's actually, maybe here is A 3 comma 6, and then it's possible that B 6 comma 2 is here, right? I hope you understand what I've drawn, right? So if we draw a vector, from A to B, this is the displacement vector, right? So displacement vector will be equal to 3 I caret minus 4 j caret meter. All right, is this clear? And the magnitude of displacement is the shortest distance, of course, right? So this distance you can find by distance formula. This distance you can find by distance formula, or you can also find by the magnitude formula that I have taught you yesterday. However you do it, you get the same answer, and that is going to be 5 meter, right? However you do it, you get the same answer, right? That's what nature is all about. Delta x nahi falak, delta r. Unit 5 meter, Krisha. Okay. All right. Uh, so that is for the first answer, right? This is it. Okay. Let's go to second. Draw a rough sketch. Draw a rough sketch of this vector, and what is the angle that it makes with positive x direction and with positive y direction. I think you would have done it. What's the answer of this, everyone? Can you tell me what's the answer of this? What's the angle with positive x? What's the angle with positive x? Okay, Raj. અરે ગ્રેસી 4 કેવી રીતે આવે? એંગલ આવો જોઈએ ને. ઓકે, ઓકે, right. So let's see. So rough sketch coming up. Right, let's say this is vector a. છે ને, નામ શું આપ્યું છે? હા, this is rough sketch. So we have to find this angle first. All right, so clearly this is ay and this is ax. See, everyone, compare it with this. The standard form is ax I caret plus ay j caret, isn't it? So clearly ax is equal to 2, ay equal to 2 root 3. All right, so from that I can easily do it by tan theta, it is equal to ay upon ax, it is equal to root 3. Clear? So theta is 60 degrees. So angle with positive x axis is 60 degrees. So this angle is of course 30 degrees. Yes, 30 with positive y, 60 degrees with positive x. Okay, right? Okay, let's go to the next question. A very simple one. Okay, આનો આન્સર હું સીધો લખી નાખું છું. I will not explain it. From this to this. Sorry. Right. Okay, minus 4 I caret plus 4 j caret. That's it. This is the answer of the PQ vector in standard form. Clear? Okay. Next question. So again, more or less similar, right? AB vector in standard form. Okay, so if we write AB vector in standard form, once again it's going to be 1 I caret plus 1 j caret. Okay, see, you can also write it simply as I caret plus j caret. Every time you want to eat an apple, you don't have to say I want to eat one apple. Okay, you just say apple, that's enough, right? Okay, so there's no need to write 1. All right, so this is what we have. Now find angle between AB vector and positive x direction. All right, so this is very easy. Again, draw the diagram, it always helps. અહીંયા find કરવાનું છે. So this is ay. Okay, let's call, let's call this vector maybe c vector. All right, let's call this c vector. So this is cy and cx. So tan theta here is going to be cy upon cx, that's 1. So theta is 45 degrees, right? Very easy to do. Yes, 45 degree with the positive x axis. Remember everyone, this is 45 degree, this is 45 degree with positive x axis, right? Suppose the same question would have been this. Okay, what would be the answer in this case? What would be the answer in this case? Any idea what would be the answer in this case? I'm waiting for you people. અરે વંદન શું લખી નાખ્યું? એંગલ પૂછ્યો છે, નોર્થ ઓફ ઈસ્ટ એવું ક્યાં આવે? નો, ઇટ ઇઝ નોટ ગોઈંગ ટુ બી -45. ગમે ત્યાં પોઝિટિવ નું નેગેટિવ કરીએ એટલે નેગેટિવ જ થઈ જાય એવું ન હોય. ઓકે everyone, so please be a little bit careful. ડ્રો ડાયાગ્રામ્સ તો જ આવડશે. અહીંયા છે ને આપણે નેગેટિવ એક્સ ડ્રો કરીએ. સો ધીસ ઇઝ નેગેટિવ એક્સ, ક્લિયર? ધીસ ઇઝ પોઝિટિવ એક્સ. સો વી હેવ ટુ ફાઇન્ડ ધ એંગલ બિટવીન નેગેટિવ એક્સ એન્ડ ધ વેક્ટર. આ ભૂસી નાખવાનું કંઈ કામ નથી, આ ફાઇન્ડ કરવાનું. ક્લિયર? So this is clearly 135 degrees, right? But in clockwise. So you could say that this vector C makes angle 135 degree clockwise with negative x axis. Clear? Is this clear everybody? અહીંથી આમ છે 135 degree. Okay, yeah, so you could write -135, that's also okay. આ તો માઇનસ પ્લસ નું કોઈને કન્ફ્યુઝન ન કરવું હોય તો આપણે ક્લોકવાઇઝ લખીએ, right? Okay, so that's it. Yes, Priyansh, you can also write it in another way. All right, you can also write it in another way, that is going to be 225 degree. આમ જાવ તો આમ જાવ ને તો 225 degree clockwise or anti-clockwise થાય. I hope you understand what I'm saying. Right? Okay. Anyway, so that's it for this question. I think that was the last one. Okay, yeah, that was the last one. હવે શું શીખી ગયા? હું ભૂલી જાઉં છું રોજ રોજ તમને શું શીખવાડ્યું. Just to remind you all, or perhaps you are knowing, that yesterday the Gujarat board has declared that some topics have been removed. You might have got the news. Okay, right? The government, the Gujarat board is just trying to fool you. Okay, you know, because we are part of school, we get the official circular, right? The circular says that schools are supposed to teach. Schools are supposed to teach everything. Okay, but it will not be asked in exam. Okay, but it will not be asked in exam. Yeah, I'm coming to that point, Falak. Just give me some time. Okay. Now see the interesting thing. Let me give you an example, okay, of what they have removed. These great guys, I can't believe that they sit on such high positions, right? A very good example is from chapter 3. They have removed, listen to this carefully, they have removed position, path length, displacement, average velocity, average speed, instantaneous velocity, and instantaneous speed. They have removed this, all right, from the chapter 3. But they have not removed acceleration. Okay, but they have not removed acceleration. હવે આ કઈ ટાઈપનું મગજ વાપરે છે કે a ઇક્વલ ટુ dv બાય dt એક્સેલરેશન સમજવા માટે પહેલા એ તો ખબર પડવી જોઈએ ને કે વોટ ઇઝ વેલોસિટી. So so this is nonsense of the highest order. So please everyone, I would like to tell you that please consider that all this is wrong. Okay, we have to do everything, right? We have to do everything. Okay, અને પાછી equations of kinematics છે હો. See the interesting thing. Okay, equations of kinematics are still there, right? Okay, anyways, but what you consider is you don't follow, I mean, you don't worry too much about what they have removed. Okay, right? So let me tell you just one thing. For JEE or for NEET exams, new syllabus has not been declared. Listen to this carefully. Okay. Yes. For JEE or NEET exams, new syllabus has not been declared. And anyways, you all are going to give this exam in 2022, right? Okay, you are going to give this exam in 2022, not in 21. So it's quite likely that when you give your JEE NEET exams, you will have the whole syllabus. So we will, as far as physics is concerned, I can tell you that you just ignore that they have removed syllabus. Okay, we have to do everything. All the topics are necessary, right? All the topics are necessary, right? If there's something that we don't really need, I will tell you, right? Trust me on that one. Okay, so please, I just like to request you that if you get access to that list and then you see that I'm teaching you something that has been removed, then don't try to question me, because like I've said, it is, they don't know what they are removing. Okay, they really don't know what they are removing, right? Okay, fine. So for JEE and NEET exams, you'll really have to do everything anyways, right? But even for board exams, you see, I want all of you to make it clear. If you don't understand all of this, there's no way you can survive 12th standard, right? You will have to use displacement and velocities and this, that, everything every time. From chapter 5, they have removed laws of motion. Chapter નું નામ જ laws of motion છે people. Chapter number 5 is laws of motion, and they have removed the first, second, and third law of motion. What a joke. Will we be able to finish the whole course? Yes, Kavya, we will be, right? We will be. Because your annual exam is in June, right? And see, frankly, I'll tell you the inside secret. 11th standard annual exam, nobody takes it seriously, right? Yes, Krisha, rest assured. 11th બોર્ડ એક્ઝામ, અરે 11th તો એક્ઝામ કોઈના કામની છે જ નહીં, બરાબર? એ તો આપણે સ્કૂલમાં જ લેવાની છે, જલસા કરો. 12th બોર્ડ એક્ઝામ સુધીમાં અને નીટ જેડબલ્યુ જે કંઈ આવતું હશે ત્યાં સુધીમાં બધું થઈ જશે વ્યવસ્થિત. ઓલરાઈટ, સો પ્લીઝ ડોન્ટ વરી અબાઉટ ઇટ. ઓકે, right? They are saying schools might, I mean, government has allowed, central government, but Gujarat government has not allowed, so we can't open, right? Okay, fine. Now let's I think this general information is good enough for you at this stage. Let's go back to learning physics. Now, so yesterday we just talked about this, that if you have got a vector like this, you can find its magnitude using this simple formula, right? I want all of you to remember this formula. It's very important. Okay, right? Now, let's go to the next thing. See, why are we writing all the vectors in form of such symbols and everything? Okay, couldn't we just live with drawing vectors? First I taught how to draw vectors, and now I'm teaching you how to write vectors. Okay, right? So why are we shifting from this to this? Because although drawing is good, right, it makes sense, you can do imagination, very very good, no problem. But there are some things that are very easy. There are some things that are very easy when you write. Okay, for example, addition. Here we go. Addition of vectors. All right, you are not going to believe how easy this is. Addition of vectors. Okay, by components. Right. So when we write the vectors in standard form, that is, we write their components and we add, let's see how easy it becomes. Suppose there is a vector A, which is, let's say, ax I caret plus ayj caret, and let's say there is a vector B, which is bx I caret plus byj caret. Then simply a vector plus b vector is equal to this. આનાથી easy કંઈ જ હોઈ શકે નહીં આ દુનિયામાં, right? See, this is just like if someone tells you what is 3x plus 4y. Suppose let's call this m, and let's call this n, which is 7x plus 2y. Then how much is m plus n? How much is m plus n? Okay, આવડી ગયું ને? 10x plus 6y છે, એવું જ આ છે, right? See, you can definitely not add 3 with 4 or 7 with 2, right? So here also same thing happens. Clear? All right, it's as simple as that. So for example, suppose you have been given that a vector is equal to 3i caret plus 4j caret, and b vector is equal to 1i caret plus 2j caret. Okay, then a vector plus b vector will be equal to 4i caret plus 6j caret. આમાં હું આગળ કંઈ જ સમજાવવાનો નથી, that's it. Okay, right? Okay, and you see this actually does follow triangle law of addition. Let me show you how. Okay, I'm really kicking myself. I should have actually made a simple chart, right, using some software. But anyways, so let's say that this is that vector a. All right, so this length is 3, correct? X component 3, and this length is 4. All right, so from here, if I follow the triangle law. Okay, so I'm going to draw one more vector. I'm going to draw one more vector, right? Okay, that is 1 I caret plus 2j caret. And let's say it's like this. Okay, let's say it is like this. So this is B vector. Clear? So this length shall be 1 and this length shall be 2. Figure not to scale. એટલે બહુ એવું ન કહેતા સર આ કેમ 1 મોટું છે 2 કરતા. Okay, so we have it like this, right? So now if I want to find A vector plus B vector, see we are following triangle law. I hope you are seeing that. We are following triangle law of addition, right? So if I will draw the addition vector from the tail of first to the head of last. So do you clearly see that all the way from here to here should be 4? Why should it be 4? 3 and 1. Yes or no? Did you understand this? So આવી ગયું ને 4 in horizontal, 4 I caret, and just like that this is 4 અને અહીંયા આટલું 2 છે. So if I draw that 2 here, then this is 4 plus 2 6. હાલે લે આ triangle law છે, but when you write it in form of this is amazingly easy. I hope you understood this, right? Okay, so this is the good thing about writing. So if you remember at the start I told you why do we write. I told you that by drawing we can get imagination, right? You can understand what's going on, but writing and doing things is very easy instead of drawing, correct? So you can clearly see that if I just add them like this, then I don't even have to worry about drawing triangles or anything, right? Result is the same, right? Clear? Addition is clear, everyone? Final yes or no? Addition clear? Okay. The same rule holds for subtraction. All right, the same rule holds for subtraction. चलो एक फटाफट करना है, right? I'm just giving you one stupid question. Okay, no more than 20 seconds, everyone. No more than 20 seconds. All right, so I want you to find this. Do it, come on. Do it. Subtract. Okay, instead of adding, subtract. A vector minus B vector. Finished. Hurry up, come on, people. All right, I think that is good enough. Minus 1 I caret plus 1 j caret. ઓકે, ખાલી એડિશન સબટ્રેક્શન ની મિસ્ટેક ન કરતા તો આવડી જ જશે, આમાં કઈ છે જ નહીં, રાઈટ? સો ધેટ્સ હાઉ યુ ડુ એડિશન સબટ્રેક્શન. ઓલ રાઈટ, ધેટ્સ હાઉ યુ ડુ એડિશન સબટ્રેક્શન. હવે ચલો થોડુંક અંદર ડીપ ક્વેશ્ચન પૂછો, એટલે જોઈએ તમારા કન્સેપ્ટ કેટલા ક્લિયર છે, રાઈટ? ઓકે, ના ના આ બહુ અઘરું થઈ જશે, રહેવા દો. આટલું જ કરો ને, ચલો વાંધો નહીં, આટલું જ કરો. ફાઇન્ડ એક્સ. ઓકે, જસ્ટ ડુ ઇટ, દેન આઈ વિલ થિંક on depending on how you are doing it. Okay, come on, find this. Come on. પછી next step આગળ કરાવું છું. Question is clear કે કંઈ આપ્યું જ નથી? Are you all there? Can you hear me? Okay, Divya. Unit vector agreed. થીટા ક્યાં આમાં ફાઇન્ડ કરવાનું છે? થીટાની કાંઈ જરૂર નથી આવ્યા. Okay, this is not related to theta. Everyone, has anyone got any idea? Did anything click in your mind? Falak, you have got one answer. There are two correct answers. Yeah, now it's right. Okay, everyone, have a look here. Look at this symbol. What's this? આ શું છે? Yes, it means that magnitude of this is 1. Clear? Clear or not? Okay. If magnitude is 1, what's the formula of magnitude? How do you find magnitude here? How do you find magnitude here? If you are given a vector in this form, how do you find magnitude? What's the formula to find magnitude? What's the formula to find magnitude, everyone? If vector is in standard form. No, Priyansh, what you are writing is unit vector. Re, Jai, Kavya, no, not right. Yes, Falak, that's right. Are bhuli gaya. If there is any vector of this form, then you find magnitude by doing this. Yes or no? Yes or no, everyone? So here, is this clear? I'm going to pause over here. Is this clear? So this, this is actually going to be the difference between 10th and 11th, 12th. It should click, but because there are so many concepts, right, by looking at the question, it will be tough for you to decide how to do it, right? Correct? એક સિમ્બોલમાં આખો મીનિંગ છુપાયો હતો. આ ક્વેશ્ચનનો મીનિંગ આખો અહીંયા જ છે. If you ignore that, you will not get it, right? So this is equal to 1. Now you have to solve it. Come on. Now you have to solve it. Yes, you're right, Falak. Practice is very important. Now you have to solve this. So square both sides. Okay, rest is maths. No, Ankita, it's only one correct answer. There are two correct answers to this question, people. So x square is 1 by 2, right? So x is equal to plus or minus 1 by root 2. These are the two correct answers. Okay, these are the two correct answers, right? Okay, all right then. Try this now. Okay, so you can actually remove this if it won't matter, right? So we are given two vectors, a vector and b vector, right? Oh, sorry, I should put minus here. I'm just sorry, I changed it. I'm so sorry. I made a mistake in writing over there. I just changed this to minus. Okay, now you do it. Okay. Okay, Neil, are you sure about that? Sahil, sure about that? I, I'd say check your answer. Okay, Jaikit. Uh, I don't think your answer is right, Jaikit. Falak, yours as well. I don't think it's right. Okay, I've not got any. I don't think I've got any correct answer so far, right? No, okay, I have. Sorry, sorry, sorry. Yeah, Vandan, your answer is right. Vandan, your answer is right. Kavya, no, Kavya, you have to find y. Y is not a vector. Yes, Dia, it's right. No, Falak, y is not a vector. Y is going to be a number, right? B is a vector. Okay, let's do it. Let's do it. Okay, so first of all, we have to understand what we are given. We are given that this is a unit vector. All right. So let's find a vector minus b vector first, so that we can do by easy subtraction here. Right? I don't think you have any problems with that. Right? Okay. I don't think you have any problems with that. Now it is given that magnitude, I hope all of you remember this symbol. Magnitude of this vector is equal to 1. Clear? Magnitude of this vector is equal to 1. Unit vector. Don't forget that. Right? Unit vector. So its magnitude is 1. So now if I find its magnitude, do you all understand? Okay, when I write this step, I want you to tell me yes or no. Do you understand that this is going to be this? Is it clear? Is it clear, everyone? Okay. Let's solve this mathematical equation. Let's solve this equation. Square both sides again. Right? So what do we have? What no, Sahil? What's not clear? This square root thing, magnitude formula again, under root x component square plus y component square. This is magnitude, right? So what's the magnitude here? This is x component and this is y component. So put those here, right? Okay, so this gives you 4 minus y whole square is equal to 0, right? 4 minus y whole square is equal to 0. So therefore 4 minus y is also 0, and that is only possible if y is equal to 4. So yes, one, then your answer is right. Okay, and some of you got it right. Okay, I do see some of you got it right. Raj, your answer was right. Dikshita, your was right. Okay, Kavya, you wrote 4j hat, but we just have to find y. Clear? So y is 4. All right, everyone understood this solution? Okay. Now let's go to the next thing. Multiplication of vector with scalar. Multiplication of vector with scalar. You might say, sir, we have already studied it. Yes, we have. But this time we are going to talk about it in a very easy way. Gracie, contact me personally, right? I think others didn't have problem with that, so I'll just explain it to you personally. That would be better, right? So multiplication of vector with scalar. Earlier we have seen that we can write vectors like this sometimes. Okay, we need to write it like this. Okay, so b vector is k into a vector, right? I hope you remember those relations like this, that b vector's magnitude is equal to k in a modulus into this, right? And about direction, k is greater than 0, k is less than 0. I hope all of you remember that. Now all of that once again becomes very simple if you write vectors in standard form. So let's say, suppose you have been given a vector which is equal to ax I caret plus ay j caret. Okay, then if you write that b vector is equal to k into a vector, then this is going to be simply equal to this, right? Which you can also write like this. What did we do? We just multiplied k inside the bracket. Clear? So this looks like, if you take an example, suppose this was 2i caret minus 3j caret, and let's say that b vector is equal to 3 times a vector. Okay, suppose b vector is equal to 3 times a vector, then I'm sure you just realize that this is just going to be a vector plus a vector plus a vector. So आप 3 times add करो, तो 2 plus 2 plus 2 is equal to 6 I caret था जैसे. I hope all of you realize that 2 plus 2 plus 2 I caret, so 6 I caret, and minus 3 minus 3 minus 3 minus 9 j caret. This you can also see is equal to this. Clear? So I hope this relation is clear for everyone. Okay. All right then. Okay, so let's test your maths. All right. Is the question clear to all of you? Meaning, okay, I will guide you on how to solve it. Is the meaning of the question clear? Can you, can everyone hear me? I doubt that. Can everyone hear me? Okay, looks like you all can. Fine. So see what is given in this question. What is given in this question then? Displacement is given, right? How much is displacement? Okay, let's write it here. It's given as 3I caret plus 6J caret and it is in meter. Okay, SI units. Right. Then this is happening over a time interval of 3 seconds, right? That is also given. Now we have to find average velocity. Okay, what's the formula of average velocity? What is the formula of average velocity, everyone? અરે આ ચેપ્ટરમાં નહીં, આની પહેલાના ચેપ્ટરમાં આવી હતી. હા, yes. Many of you are saying, it is delta x upon delta t. Yes, but there we were using those symbols. The basic idea is it is displacement divided by time interval. Correct? It is displacement divided by time interval. No, Arkan, it is wrong. Raj, it is wrong. Okay, it is displacement upon time interval. So displacement here is delta r vector upon time interval. Clear? Clear or not clear? Sahil, it is wrong. अरे यार बहु उतावड़ा हो, बहु उतावड़ा. Focus on what I am saying. પહેલેથી આન્સર ફાઇન્ડ કરવાની બહુ ટ્રાય ન કરવી. So delta r vector upon delta t. Is this clear, everyone? This is average velocity. Right? This is average velocity. Full question દેખાડું? Okay. Right? So just divide. આવડે ને divide કરતા? Arkan, are you present? This is time to answer a question that you asked me earlier, many days ago. Yeah, you don't remember, but I'll tell you, I'll give you the answer, then you will be able to remember. I mean, you will be recalling it, I'm sure. Yes, the answer is going to be average velocity. The answer is going to be that average velocity, it is a vector. હવે આમ લખવું પડશે. Symbol has changed. Warning. Symbol has changed. Right? It is equal to 3I caret plus 6J caret, the whole divided by 3. આમ લખવું પડશે ને? Right? The whole divided by 3. So this is equal to 1I caret or just I caret plus 2J caret meter per second. People have forgotten the unit, it seems. People, you didn't write the unit. So many of you didn't write the unit. Meter per second. Okay. જોયું આટલા બધા આન્સર જોવાના, તમે શું લખો છો એ વાંચવાનું અને અહીંયા લખવાનું તે મારે અને બોલવાનું તે. Still I could manage to see that you are not writing units. Okay, so just be a little bit careful. All right. So this is average velocity. Clearly this is a vector, right? Last chapter માં તો કેટલું બધું સમજાવ્યું. It's a vector. It has a direction. It's a vector. Right? Now I hope it becomes clear why it should be a vector, right? Also, now comes the answer to your question. Now comes the answer to your question. Where do we need? Where do we need to multiply a vector with a scalar? I hope you have at least got some idea to your answer, right? You asked me this question. Why do we need to learn to multiply a vector with a scalar? This is a very good example. You see, average velocity is a vector. So our relation છે ને આના જેવું જ છે. I hope you get what I'm saying. I hope you get what I'm saying, right? This relation is just like this. This is average velocity equal to some 1 by 3, which is actually 1 upon delta t into this. Clear? Right? Okay. And not only that, can someone comment upon direction of average velocity and displacement? Can someone give me some input, some idea about direction of these two? What would you like to say about direction of these two? What would you like to say about direction of these two? પોઝિટિવ ડાયરેક્શન હોય એવું કોણે કીધું છે કે નેગેટિવ હોય? રોંગ રાજ, ઇનકરેક્ટ કન્ક્લુઝન. યસ ફલક. નો કાવ્યા, ક્રિમા, no, not possible. Both not possible, of course. Yes, Preet, very good. લે યાર તમે લોકો બરાબર વાંચતા નથી પોઈન્ટ્સ, હે? બહુ તકલીફ પડશે હો. પછી 11th માં આગળ છે ને એવું આવશે કે why do two masses attract each other? તો એનો આન્સર હું આવી રીતે આપીશ, પછી તમને ખબર ન પડે તો કહેતા નહીં. I will repeat, I will warn you once again. So many things depend on this, right? પછી ત્યારે એમ ન કહેતા કે આ ડાયરેક્શન વાળું આવડતું નથી. ઇન્ક્રીઝિંગ કહે છે, બોલો એ રાજ નોટ્સ વાંચતું જરાક હવે, નહીતર ફોન કરવો પડશે મારે ઘરે, હવે કઈ વાંચતો નથી. People, here if k is greater than 0 then direction should be same, બરાબર ને? Right? Direction should be same. Let's see. Time interval. I hope all of you realize that time interval is always positive. Yes or no? I hope everyone realizes that time interval is always positive. કોઈ દિવસ time interval negative હોય? Think about it. પહેલા 5 વાગે, પછી 4 વાગે, ઈ જ દિવસે. Time interval is always positive, correct? So if time interval is always positive, so this whole thing is always positive. So that means k is positive. I hope you understood that. So we can always say that average velocity and displacement are in same direction, whichever direction. Positive hoye એવું જરૂરી નથી, people. Raj, this is for you. Okay. Raj, Jaikit, you said it will always be positive. Krima Kavya, you said both positive, negative. No. What is the truth? It is that both are in same direction, whichever direction it is. North hoy to be north. North hoy to be north, south hoy to south, west hoy to west. Okay. Clear? Both are always in the same direction. Is this clear, all of you? Everyone, okay? It's not just important for 2 or 3 people. This is for everybody. Is this clear? That why both of these are always in the same direction? And I promise that we use this at least 20 times in these 2 years. Let me tell you that we are going to use this at least 20 times in these 2 years. ચલો એક બીજું એક્ઝામ્પલ આપી દઉં જતા જતા. Do you remember? Oh, યાદ હશે કે નહીં ખબર નહીં. Do you remember that if acceleration is positive, then velocity increases? આ કોને યાદ છે? How many of you remember this? દસ લોકો તો ભાગી ગયા, કઈ વાંધો નહીં. Okay, so sorry, the connection might have got poor. Do you remember this, people? Do you remember this one? Okay, yes, I know there is some network problem. So I'll rely on writing, okay? Okay. This is because actually acceleration is a vector and its correct relation should be written like this. Okay, એવું આવશે આ ચેપ્ટરમાં. This is a vector, this is a vector, but this is a scalar. So if you look at this relation carefully, it is just like this. Okay, right? So this is again of the type b equal to k into a vector. So if we have acceleration positive, if we have acceleration positive, right, if this is positive, that is in the positive direction, then dv, this is also going to be in the positive direction or positive. And I'm sure you understand that if change del, I hope you remember that d stands for small change, right? D stands for small change. So if small change is positive, if small change is positive, then velocity is actually increasing, right? If small change is positive, the velocity is actually increasing. એ આખું એની ઉપરથી આવે છે. So there we have used it in past, we have also used it, we have also been using it here, right? And we will continue to use it many times, right? Okay, and whether you believe it or not, but even this relation is similar. I hope you realize why. Because force is a vector, acceleration is also a vector, but mass is a scalar. હવે આની ઉપર વિચારજો જરાક, right? Okay, yes, of course this is in chapter 5, but I thought I'll just tell you something about it, right? Okay, all right, then that's enough for today. Goodbye everyone. Why are you so surprised, Falok? Raj, we will come to that formula, okay? After this we are going to derive that formula, right? Then I'll tell you why to use it or how to use it, okay? Yeah, send it on phone. Okay, good enough, Neil.